Hello, this is Mr. Frazier here, and I am with Module 7, looking at polynomials. So, a few of the things that I have noticed. Polynomials, we need to know how to name them. They're named for two reasons: how many terms there are, and how many degrees they have. So as we're looking at stuff, they go through a bunch of this to explain stuff. Classifying polynomials by terms. Understanding that plus and minus is how we separate polynomials. Polynomials cannot have x's in the denominator. That's a big no-no. And they are separated term-wise by plus and minus signs. So this one would be an example of a binomial, two terms. Binomial, two terms. So looking at these examples, it's important to see that 3 is a coefficient, -4 is a coefficient, -5 is a constant because there's no variables. 2 is a coefficient. The number in front is the coefficient. A degree for this first one would be 4. The degree for the second term is 3 because you take the exponents and you add them for the variables. It's just the variables. So y has an exponent of 1. 1 and 2 is 3. X has an exponent of 4. So this is a 4th degree binomial. This one would be a monomial. Why? It's one term. The coefficient is -6. The degree of this term would be 4 because x is to the third power, y is to the first power. So it's understanding how you're naming these things that is a critical piece. And there they go. They show you what it means to the degree. It's understanding that you have the 5th degree because x is to the 1, y is to the third, z is to the 1. So many of you I see getting this right, but then you forget about it as we move forward. So the degree of a polynomial is not too difficult. Putting it in standard form means you put it from the highest degree to the lowest degree. All right, so there's a lot of activities that work with this. Now the next thing that I noticed is that not just dealing with a degree, but now dealing with addition. Now addition never seems too hard because you line up the correct matching terms, like terms, things with like variables. The part that becomes more confusing is when we do subtraction, because when we have a subtraction problem, you have to remember to, like this one, take the negative sign and distribute it. Now there's a whole video on this, and I'm hoping that you guys are using these appropriately, but this would become -13x and -2. So now you'd have 4x minus 7 plus or minus 13x minus 2. Because there's a negative sign, that changes the signs of everything inside the parentheses. And then you just, I like lining them up. So it'd be 4x minus 13x and -2 or -7 minus 2. So they go through both of these, the horizontal and the vertical method. I had some of you telling me that this was an addition or a multiplication property, but it's not. It's a addition piece. And there is a video here that shows you exactly how to do it. Hopefully you guys are watching these. Next would be understanding of how we multiply. And there's a couple different ways we multiply. Now remember, this is just quick and out of the box. These are things that you should be doing while into this. So as we get into multiplication, when you're multiplying exponents, when you're multiplying variables, the exponents change. I use the acronym ACME. When you add, the coefficients are changing. When you multiply, your exponents change. So when you're adding variables, the coefficient changes. When you multiply variables, that's when you're going to have the exponent change. Why? Because the exponent is a shortcut for writing multiplication problems. So x times x isn't 2x, that's x plus x. Adding coefficient changes. 1x plus 1x is 2x. Multiplying x times x. When you multiply x squared, the exponent changes. It comes from 1 to 1 to 2. So x squared times x squared is x to the 4th. The exponent changes. Why? Because we're multiplying. X squared plus x squared is 2x squareds. Why? Because we're adding. So you have to know the difference between whether you're adding or multiplying. And this goes all the way through. Multiplying of monomials, which is pretty easy. And then we talk about the box method as well as the distribution method. There's two different ways. Okay, Now going on to the next one, which is division of polynomials. So obviously, if you're multiplying, your exponents get bigger. If you're dividing, then your exponents are getting smaller, right? So that means we're adding exponents when we're multiplying, and we're subtracting exponents when we divide, correct? And then it's understanding of where those exponents go and what you're doing. And this is expanded form and showing you how you can cross-cancel all of these. These are excellent helps. You can do them long way every time you work. All right. Remember, this is just a brief overview. These are the things you should be practicing, okay? Some of these practice things go into your gradebook automatically, so it's important that you do them all. And here we have the product powers, that when we raise a power to a power, we multiply them. When we do a multiplication of two like terms, we add the exponents. When we divide, we subtract them. So many of these things are very important, just like negative exponents, that anytime you have a negative exponent, you make it a positive by flipping it over the fraction bar. Why? Because a positive exponent tells me to multiply. So a negative exponent would tell me to, hopefully you get it, divide. Right, that's what happens. That negative sign makes me do the opposite. So a to the nth power tells me to multiply. If it was to the negative n, it's telling me to divide. If that negative exponent was in the division part, that would tell me to do the opposite of that, which would then be multiply. So you can see how moving it over the fraction bar changes it from a negative to a positive because you're changing the operation. Then, of course, last but not least, anything to the 0 power is always 1, which is confusing because you're used to saying anything times 0 is 0. Bringing to the 0 power is not the same as multiplying by 0. So you have to think powers are a little different. Then as we get to the multiplication of polynomials, it's making sure that we distribute or we use the box method. So hopefully you're paying attention to how both of those are done, and you practice. The only way you get better at this is by practicing. Notice this looks similar to the adding and subtracting, but there's no adding and subtracting. This one's multiplying. So that means you're taking 2x squared and you multiply it by 3x squared, multiply by 6x, multiply by 2. And then you're going to do the same thing for the next term. And you do the same thing for the last term. Then you're going to add like terms. It shows you how to do all this step by step. So hopefully you're watching these videos explaining what you're supposed to do. Alrighty, same goes for the division. And that's where we're going to next, the factoring of a polynomial, which then becomes really, really important. Special products is something that you're going to see related to factoring, special factoring things. So there's certain things that you see that have a pattern when we multiply, and then when you see that answer, you're going to know what the pattern was when we divide. So you're introduced to them here, and you'll use them a lot more in the next module. So you want to start seeing how does this pattern, how do those numbers reflect each other, so that you understand, hey, wait a minute, if I see this answer, it means it started like this. This is one of the ways that I believe is the easiest way to multiply, because it looks like a Punnett square like you used in science. And you'd have big R, little r, big P, little p. And you could tell me the two big R's meant it was supposed to be red, and the little p means it was supposed to be a pea pod or not a pea pod. So these are patterns to explain what happens. So when you have something like this, 3x plus 3 squared, it's going to be a pattern. X squared plus 6x plus 9. Something always happens. This gets squared, this times 2, and the last term squared. That's what this problem is. And they go through several examples. Hopefully you're watching those examples and writing on your notes. Okay, so last but not least is dealing with those special products. Then schedule your DBA, and we're going to talk about these things. I'm going to ask you those specific types of questions. Hey, explain to me how you multiply. Explain to me how you add. Explain to me how you subtract. And hopefully you're able to give me concise answers. All right, guys, thank you very much. I look forward to grading your work.